Imagine you just finished building a brand new banking application. You've verified the login, the balance checks, and the money transfers. Everything appears to work, so you release it to the public. The next morning, a customer attempts to transfer 10,000 rupees, but when the data reaches the receiver, a hidden flaw multiplies the amount. The receiver gets 100,000 rupees. This is a massive, immediate financial loss. Now, another user simply enters the wrong password. Instead of returning a standard warning message, the error cascades and the entire application infrastructure shatters. It crashes completely. Programmers make mistakes, but the failure here is a missing safety net. This software was released with incomplete or missing testing. Before we can effectively test a system, we have to know exactly what we are hunting for. In software engineering, we call this target a bug or a defect. Let's look at a very basic programming scenario. Suppose we want to write a program that adds two numbers together, 10 and 5. We define our variables, and we write a print statement for the output. The expected output here is 15, but if we run this, the actual output is 5. Looking closely at the code, there is a minus sign where the plus sign should be. That single incorrect character is a bug. It is any error in the software that creates a gap between what the program is supposed to do and what it actually does. Because bugs can hide in plain sight, testing must be a systematic engineering process. Think of civil engineers evaluating a new suspension bridge. They first stress test its load capacity before letting thousands of cars drive over it. Software requires the exact same rigor. This engineering rigor has measurable objectives. First, actively hunting down defects and verifying the software meets the client's strict requirements. Beyond that, testing improves code quality, increases system reliability, and ensures the end user is satisfied. Testing focuses on identifying flaws early rather than claiming mathematical perfection. The purpose is to systematically trap errors before your customer is forced to deal with them. Let's clear up common misconceptions. First, the bug-free fallacy. Finding 0 bugs doesn't guarantee perfect software. It only reduces risk. Second, finding edge cases takes significant time. Third, quality is everyone's responsibility. Lastly, software that runs can still produce incorrect results. Building reliable software requires accepting that quality is an ongoing discipline of risk reduction, not a simple pass or fail checkbox. So, how do modern development teams physically execute this process from start to finish? This flowchart maps out the testing algorithm. Everything starts by analyzing the core requirements. Based on those, engineers formulate specific test cases and execute those tests against the software. From here, the workflow splits. If a bug is discovered, the code routes back to developers for fixing and retesting. If the test passes completely, it flows straight to final release. Take a look at the workflow. If a tester enters a password and notices the app crash, exactly which node on this flowchart are they currently occupying? They are at the run test stage, right before hitting the decision diamond. This entire structure proves that testing is never a random hunt. It is a rigid, engineered algorithm built specifically to trap errors before they escape. There is a strict division of labor in this algorithm that beginners often confuse. Think of the software lifecycle like a school exam. Writing your answers is coding. Checking over your work before you submit it is testing. And erasing a mistake to rewrite the correct answer is debugging. Testing is the distinct act of finding the defect. This action is usually performed by quality assurance engineers and testers. On the right, we have debugging. Debugging is the act of actually fixing the defect, which is the primary responsibility of the developers. High-quality software relies on sound design, clean coding, and thorough testing. Code alone is never enough. Furthermore, professional engineers never test massive systems all at once. Instead, they break the problem down. Next lesson, we'll examine the 4 specific levels of software testing.